Well, hey, rock stars! Get ready for another exciting episode of Rock Talk. Wow! We're back at Turtle Rock at Ring Mountain, Marin area, California kind of stuff, to talk about the last in our three-part series of the different kinds of rocks. Today is going to be all about the mighty, magical, metamorphic rocks. Whoa! But what is a metamorphic rock? A metamorphic rock is very interesting because it can form from any kind of rock. You can form a metamorphic rock from a sedimentary, an igneous, or even another metamorphic rock, simply by just applying heat, pressure, or change in chemistry, or all three of those things at once. You can form a metamorphic rock. Unlike an igneous rock, pressure, temperature, and the change of chemistry are being applied to this rock, but it is not melting. If you melt that rock, you've gone too far. Now you're an igneous rock. So all that pressure can be applied to that rock, and all that heat and everything's happening, but it's just not gonna melt. Instead, it's going to alter in some way. It's going to change. It is going to undergo a process called metamorphosis, where the actual minerals in that rock start to change. The atoms in some cases will rearrange from different minerals, and you'll form entirely new rocks as a result. Really cool, really super interesting and neat, and probably the most difficult kinds of rocks to understand because it can get so incredibly convoluted and complicated. It's really wild and crazy. But what you need to know, my friends, my rock stars, if you are out in the wild looking at a metamorphic rock, you can very simply, very easily divide it into two categories. It is either going to be a foliated igneous rock or a non-foliated igneous rock. Now, what does that mean? So, foliation is a process that forms under rocks under a lot of pressure. Metamorphic rocks under a tremendous amount of pressure, the minerals in that rock are actually going to start to organize themselves on parallel axes, especially really platy minerals. Minerals like micas, when you apply pressure to them in this direction, so you are squeezing a rock in this direction, the minerals are going to organize in parallel lines perpendicular to that axis that you're pushing on. So if you're applying pressure like this, applying pressure in this way, you're gonna get parallel lines like that. Kind of like that. I'll throw in some B-roll, it'll make more sense. There's actually, you can actually just, I don't know, you can see right there. Whoa, you can see right there. So you've got all those parallel little sheets right there that have formed, and that's due to pressure that rock has been applied to. Tremendous amounts of direct pressure and contact. So those foliations that form under high amounts of pressure, tremendous amounts of pressure, are traditionally going to be associated with things like continental collisions, where the plates of continents are colliding in these giant battles of epic proportions. And that is called regional metamorphism because it is a wide scale kind of metamorphism that can affect, in some cases, the entire sides of continents. It is tremendous. For non-foliated rocks, the rock has been applied to more heat than pressure. In this instance, we are talking about just baking that rock at temperatures that are just enough to alter its chemistry, but not enough to melt that rock. And that is going to form different kinds of minerals, but isn't going to include any kind of foliation there. So that is a major important distinction. They're not going to have those parallel bands, those sheets that form in a non-foliated rock. It just doesn't have it. What that tells you at that point is that a non-foliated rock has been applied to, again, a lot of temperature, and that is associated with something called contact metamorphism, because that metamorphic rock came in very close contact with a very hot magmatic body, and most likely an intruding magma chamber of molten liquid rock. So it's going to be very close to the origin of an igneous rock, but not quite melted yet. So it's just so close to that cutting edge of being melted and turned into an igneous, but it's just far enough away to still be safe, to still be okay. This is all poison oak too, by the way. That's insidious. Terrible. Damn you, bio crap. Yeah. Anyway, what was I saying?
It's poison oak. That's a horrible place to have that. Oh God.
That's really quite horrifying. Tell your friends, hide your wife, hide your friends, tell your wife. Getting all kinds of itchy up in here. Itching people up. Yeah. Is it, I'm like the shot? Yeah, all right, cool. We've talked about certain metamorphic rocks before, like this piece of blue schist here we've already talked about, which is a nice big piece of metamorphic rock, a foliated rock. But we've also talked about greenstone before. Greenstone is a non-foliated metamorphic basalt. And then also as well, the state rock of California, serpentine, is also a metamorphic rock that forms under crazy amounts of pressure and varying chemistries there, which is just super cool. So, you know, whenever you're out on a hike, rock stars, feel free just to look around and try and sniff out, you know, what kinds of rocks are which. And remember, with a metamorphic rock, you're looking for one of two things, whether it's a foliated rock, meaning that it's been put under a lot of pressure and the minerals in that rock have started to align themselves based off of the directions of pressure, or a non-foliated rock, which basically means that it was baked with a lot of heat. So that kind of concludes our three-part series on sedimentary, igneous, and metamorphic rocks. Take a look there. I hope that that can serve as a cool guide if you are looking at a rock outside, or if you have some rocks that you've already collected at home that you're curious about. Feel free to you know, kind of apply what I've taught you and use that. And especially get out there, get outdoors, put your hands on some rocks, rock stars. You gotta touch the rock. You gotta feel the rock. You gotta be the rock. And then you'll know what it's like to be in a rock band. In all seriousness, seriously, if there's anything in this video that was a little confusing that you would like me to explain in more detail, please let me know. I know that especially when it comes to foliations, that can be kind of tricky, because sedimentary rocks have layers and metamorphic rocks also have layers. So it can be kind of tricky to tell the difference between the two. In general though, you're going to want to really look closely and tell if it has sedimentary grains or not, because that's the really important deciding factor in whether it's a sedimentary rock at all. So if it has layers and has sedimentary grains, it's probably a sedimentary rock. If it has layers but you can't see any grains in it, then it's probably a metamorphic rock. Hoping that will help you on your journeys, rock stars. And as always, if you see something cool and you just really want to share it, feel free to post in the comments or send me a direct email containing the picture of your rock, and I will be sure to feature it on the next episode. Thanks.
Check out the other two parts of the series. They'll be up in this corner.
Oh yes, thank you, Kevin. The other two parts of the series will be up here. Ah, yes. Ha ha. Ha. Whoa, wait, what? Oh, you went too far. It's right here. It's right here. Okay, cool. Yeah, right there. Anyway, yeah, feel free to check that out. And you know, if this is your first time watching any of my videos, thank you so much for joining. And if be sure to smash that subscribe button and hit the bell to get future notifications. It's a puppy! Oh my God, hey buddy.
You guys filming?
Video about metamorphic rocks. Yeah.